Okay, hi, Assalamualaikum. Okay, tonight we continue paper 2 SPP, section B and C. Okay, so for this section B, you must choose one of the two questions given. 20 marks, soalan 20 markah. Look at number 9. Okay, diagram 9.1 shows the cooling curve of a gas sample at 160 degrees Celsius, cool for 25 minutes. So you can look at the graph here. Then starting from the temperature of 160, then you can see decrease in temperature. That's why we call it cooling curve. Okay, look at the first question. Define latent heat of fusion. Okay, haba pendam pelakuran. So bila bercakap tentang define or definition, you must state accurately the definition. Okay, you can write something like this: amount of heat required or needed Okay, the word fusion refers to solid change to liquid or liquid change back to solid. So this process we call it fusion. Okay, latent heat of fusion for this process. Okay, so change This is I think the BM version there's a word tentu sini tak ada, sepatutnya kena ada perkataan ini specific latent heat of fusion. Okay, put in definition dia untuk translation dia ada problem sikit lah. Okay, takrifkan haba pendam tentu pelakuran. So for the BI one should be define specific latent heat of fusion. So when there is the word specific, there must be word 1 kg. Okay, 1 kg of solid to liquid. Okay, or we can say a change in phase. 1 kg of substance. Okay. Word 1 kg to solid at constant temperature. Okay, so amount of heat required or amount of heat needed or amount of heat released. Okay, if required means change 1 kg of solid to liquid at constant temperature. So we call it specific latent heat of fusion. If amount of heat released is to change 1 kg of liquid to solid. Okay, that means for the process of freezing at constant temperature. Okay, based on that B, based on diagram 9.1, explain why temperature does not change from Q to R, but changes from R to S. Q to R and R to S. So we go back to the graph, the cooling curve graph. Okay, the question is, For this part QR, temperature is constant, but for this part R and S, you can see there is change in temperature. So for this one, amount of heat still released out from 2 to 10 minutes. Okay, so there is heat energy release. Okay, for R to S, there's also heat energy release. But why temperature, this one constant, why this temperature decrease? Okay, uh, so this one, Q to R, you can see this is the gas state, gas state, and then reach this QR by condensation, it changed to liquid. So this one is liquid state. Okay, when gas change to liquid. Okay, process of condensation. So latent heat of vaporization is released. Okay, so that it strengthens the bond between the molecules, so that the molecule of gas, when it build up a stronger force, it will change back to liquid. Okay, so heat energy release. Okay, for this RS, for this one is to form the bond between the molecules, and this one, the amount of heat released causes the temperature to drop. Okay, so how to answer this question? Macam mana nak tulis jawapan? 4 marks. Okay, so you can mention the first one for Q to R. Q to R, what exactly happened? The gas, gas condensing to liquid. Or you can say, okay, the gas changed to liquid by process of condensation. Okay, second point, latent heat of vaporization is released to form molecular bond between molecules. Okay, so that the gas will become liquid. Okay, now we look at the okay. For the next one is RS, R to S. The liquid goes down, menuju until reach freezing point. So latent heat of fusion is released causes temperature drop. Okay, temperature drop but no change in phase. Okay, cause the temperature to drop. So latent heat of fusion is released. Okay, sorry, yeah, I think this is wrong. I need correction. There's a correction. This one. So this is not latent heat. Heat capacity here because change in temperature. Carried out with the carried away with the question. Okay, careful. Liquid cools to freezing point. What is released? Heat capacity here. Okay. So heat capacity release. So these are 4 points that you can include in your answer. So there is a difference between Q to R and R to S. So ini Q to R, constant temperature, no change in temperature. So we call it latent heat. Okay, R to S, no change in phase. State of matter masih sama. Okay, so heat capacity. Part C, calculate heat energy required to change 0.5 kg of substance at 120 degrees Celsius into 100 given specific heat capacity, specific latent heat of vaporization. Okay, 4 marks calculation. Okay, 120. Look at the graph. Okay, this is the constant temperature. Okay, drop to 100. So there are two type of energy, Q1, Q2. Okay, Q1 no change in temperature, so Q1 is MLV, yeah, vaporization. Q2 is MC theta. So this one is theta 1, here is theta 2. Okay, so the total energy required is Q1 plus Q2. Yeah. The total energy required Q1 plus Q2. Okay, so MLV plus MC theta. Okay, just substitute LV, vaporization 4802 0.00 plus 0.5 C1720 multiply change in temperature 120 minus 100. Okay, okay, so you can calculate for this one, you will get the answer. So 57,200. Okay, so you want to change to kilojoule also can, or standard form. Okay, so ini you kena tahu lah sama ada you nak guna ml atau mc theta. Remember, if no change in phase, constant temperature, you use ml. If there is change in temperature, no change in phase, you use mc theta. Okay, state one assumption. Okay, no heat. Normally for topic heat, always there is one assumption. So we just write down no heat is lost to surrounding. That's the reason why we can say that the amount of energy absorbed equals to amount of energy released. Yeah. Okay. No heat loss only. Okay, part E, diagram 9.2 shows a floor plan of cluster house in Malaysia. A cluster house resembles a semi-detached house which shares back wall and side wall. This house has only one entrance door, while the windows are only at the front and the side of the house. This house design can minimize the noise. Okay, this one is the rumah teres. Kalau tahu itu rumah teres lah. Rumah yang kongsi dinding. Okay. Jadi ada banyak masalah lah rumah ni kan biasanya. Dari segi selalunya ialah kalau tajuk ni ialah berkaitan heat, maksudnya berkaitan dengan temperature. Okay. So you nampak ni design dia dah bagi kat sini. You boleh nampak there's a window, entrance door. Okay, ada design dia. Dia nampak. Level 9 shows 4 model of cluster house PQRS and developed on residential site. Okay, siapa yang pernah buat PPL? Ini adalah one of the topic in topic heat PPL. So you have the idea lah. Okay, if we have done the PPL on this topic cluster house. Okay, given also the characteristic of the cluster house, we have PQRS. Okay, let's try to find which one is the most suitable. Okay, number of windows 5, 3, 4, 2. So number of windows must be more. We want to reduce the temperature in the cluster house. So if more, I will remove 2 of 8. I will remove 3 and 2. So I will choose 5, 3, remove 4, and I remove 2. Floor to ceiling distance. So we want to produce air circulation. So we must use higher height from floor to ceiling distance. So I will remove also 2, the smallest value. So I remove 2.9 and 2.5. Material of the wall. Okay, either we use container wall panel, okay, concrete block, hollow bricks, or wood. Okay, so I don't want to use this container wall panel. This one is quite hot. Concrete block, or maybe a brick. Okay, or maybe wood is okay. And then for the material of roof, we try to prevent heat trapped inside, so we don't want same roof. So I remove same roof. I will choose concrete tile. Okay, so we can see from here, R has the most ticks. Okay, all the characteristic for R we accept, so we choose R. So answer based on your choice. R. Just explain R. So you can use table form to explain R. Okay, the first characteristic you can explain about number of windows. Why we need more number of windows? Okay. Okay, so we have 1, 2, 3, 4. Okay, first more number of windows. Okay, so what is the reason? Allow more airflow. Pengaliran udara yang baik lah. Okay. Second one, the distance between floor to ceiling is higher. Okay, or the height. Distance between floor and ceiling is higher. Okay, reason? Reason you boleh accept. Okay, better air ventilation or circulation or something. Okay, the third one, you write in table form better. So I don't have enough spaces, so I just write the point. Okay, second one, the wall is made of hollow bricks or wood. Okay, the wall is made of. So I just explained for R. R is what? Just now. Hollow bricks. So we can say it's higher specific heat capacity. Okay, okay, does not cause increase in temperature too high. It prevent the increase in temperature faster. The roof is made of concrete tile. The roof is made of concrete tile. Okay. Also say higher reason boleh repeat tak ada masalah. It will is faster increase in temperature. Okay. Maksudnya kalau hari yang sangat panas, roof itu dia prevent daripada cepat panas, cepat panas. Jadi udara dalam rumah tu adalah lebih sejuk. Okay, walaupun hari di luar tu panas. Okay, then boleh tulis R is chosen because and so on as usual. Because I just explain balik dia punya design di sini, karakteristik. Okay, number 10. Diagram 10.1 shows low resistivity connecting wire of carbon. State meaning of resistivity. When you look at the formula, so the unit is row meter unit. Okay, so this one actually represent material of wire. Okay, measure of stability of conductor to oppose the flow of current. Okay, kalau kita mention sebagai resistance ialah physical quantity that oppose the flow of current. This one is the measure of ability refer to material of the wire. Okay, material of the conductor. Explain why low resistivity connecting wire is used. Okay, this one relate to the R equals to rho L over A. Then resistivity equals to RA over L. Okay, so means relationship between R and resistivity for constant length and constant cross-sectional area is directly proportional. Okay, the lower the resistivity means the lower the resistance of the wire. Okay, so resistance because some of the electrical energy lost as heat energy. Low resistivity means low resistance. Okay, so low resistance we can reduce energy loss or power loss. Okay. So lagi satu kalau resistance is low, lower current flow. Okay, lower down the current. So this one will cause or to prevent over of conductor. Okay, prevent overheating. Okay, explain two other factors that increase conductivity of connecting wire. Increase conductivity means we can reduce resistance. So two factors that affect resistance you can see from here is L, E. Okay, the first one you can state about using short length of wire. Okay, using short length of wire. Second, when you want to reduce resistance, you use thicker wire. Okay, let's use thicker wire ataupun you boleh tulis juga sebagai a larger cross sectional area ataupun larger diameter of wire. Okay, part D. Diagram shows power rating level on the screen or on the oven. Calculate total electrical energy supplied for 90 minutes in kilowatt hour. Formula E equals to P. If you want the unit kilowatt hour, the power must be in kilowatt, the time in hour. So 90 minutes equals to how many hours? Okay, so the power here is 1200. 1200 is 1.2 kilowatt. Okay, and then the time taken is 90 over 60. You want to convert to hour. Okay, this is hour. Okay, so you will get the answer is 1.8 kilowatt hour. Okay, So unit must be correct. The power, kilowatt, time, hour. Okay, now next, what is the cost? Okay, use 90 minutes per day for 2 weeks. Tariff 21.8 cents per unit. Okay, so the total energy is equals to, for 1 day is 1.8 kilowatt hour. So you want to calculate for 2 weeks. 2 weeks is 14 days. Okay, so you will get the number of unit like this, kilowatt hour. So what is the cost? Equals to total energy in kilowatt hour multiply the tariff 0.218 cent. Okay, you will calculate this, you will get RM 5.49 cent. This is the cost. Part E shows a vapor maker power rating given. Table shows 4 type of vapor maker JKLM, different spec. Now we want to choose JKLOM, so we need to remove a certain vapor maker which is not suitable. For example, the first one, number of turns of heating element. Okay, should be more. So we accept 3, remove this one. Okay, type of material used as heating element. So this one we need to use high resistance of material in order to produce more heat. High resistance means nichrome, so we remove copper. Copper low resistance. Okay, rate of oxidation of course must be low because we want it to long lasting, does not cause rusting easily, does not rust easily. So we remove the one which is high. What is the fuse that we should choose? Fuse is 5 ampere. This one is bicarpation. You look at the level again, the current flow based on the level. Okay, this is V, this is P. So P equals to IB, I equals to P divided by B. So 1000 divided by 240. So we get 4.17 ampere. So the value of fuse must use the one which is slightly higher than this one. So slightly higher means 5 ampere. You cannot use 3 ampere. Okay, if not, this one cannot function, is the fuse already melt. So you need to use which is slightly higher than the current flow at normal function. Okay, so the most ticks from here, you can see K. Okay, so we explain K in this case. Okay, so you can have the table here, one table, you can draw one table. Okay, the characteristic, and then the explanation, the reason. I think it's better write reason. Okay, the first one explain about number of turns is more number of turns of heating element. So number of turn means longer wire, so higher resistance. Number 2, second point in the aspect. Okay, the heating element is made of is nichrome. Okay, then you going to place higher resistivity because refer to the material, or you want to write produce more heat energy, more work done to overcome resistance, so more electrical energy convert to heat, so the water will boil or the vapor will be cooked faster. Okay, now the third one is the rate of oxidation is low. No. Okay, so means you can write as not easily rust or corrode or last longer, tahan lama. Yeah. Okay. The fuse is 5 ampere. Reason the current, okay, the current flows is 4.17. Okay. So normally the value of fuse must be slightly higher. So which one is chosen? K is chosen. Okay. Apa reason? Okay, we tulis balik di sini. Okay, more number of turns. Okay, made of nichrome, low oxidation rate. The fuse is 5 ampere. Okay, so you will get 10 marks for this one. Okay, section C, only one question given. So answer this question, number 11. Diagram shows Logan sliding down a slide angle theta 30 and 45, different acceleration, frictional force Ft acting on Logan at both sides same, weight of Logan given, what Wx component parallel to slide, resultant force parallel to slide, Wx minus Ft. So already given to you the force, okay, the free body diagram, the forces that act on the coil, okay, for both slider, different angle. What is meant by resultant force? Okay, you can write, there are more than one definition. The vector sum of the forces that act on the object. Okay, so there are more than one force act, so you calculate the vector sum, so that one represent resultant force. Using diagram 11.1, 11.2, compare Wx, Fx and angle theta, relate Fx with angle theta, hence state conclusion about relationship between acceleration with angle theta 5. Okay, so compare what? 1 mark, second mark, third mark. Relate Fx and fourth mark, state conclusion, relate acceleration and theta. Okay, 1, 2, 3, 4. Okay, and write the answer. So for the first point, you just compare between 11.1, 11.2 for WX. WX in 11.1 is smaller than in 11.2. Okay, and then you compare for FX. FX in 11.1 also smaller than in 11.2. Angle theta 11.1 also smaller than in 11.2. So you have 3 marks. Compare. Do write in a complete sentence. Okay. Try to avoid using so many symbols. You can write fully in sentence. And then the fourth mark, relate fx and theta. Okay. So you boleh guna sentence like hypothesis. Okay. When theta increase, fx increase. Okay, yang pertama. Kita dapat dah first yang keempat, muka keempat. And then relate acceleration dengan angle. Okay. So when theta increase, acceleration increase. Okay. Okay. Nampak tak? Dia punya markah dia. Ini 3 markah. 1, 2, 3. Sini markah yang keempat. Ini markah yang kelima. Okay, part C, diagram 11.3 shows stationary block on smooth inclined plane when a force P is applied horizontally. W is weight of the block, is the normal reaction from the inclined plane. Sketch and label triangle of forces for P, W, R to represent situation. Okay. Okay, weight W. This is W. And there is a normal reaction. Okay. Reaction. Okay, normally when we want to draw, we draw the one which is a horizontal or vertical first. Okay, so let's say I draw the one which is vertical, means W. So W, yeah. This one is sketch, so no need to measure anything. We don't have scale. Vertical, sangat sikit. Vertical W, guna ruler, okay, and then followed by P, and then continue this one. Okay, W and P 90 degrees. We have R here. So direction like moving in one circle. Okay, nampak follow each other. So ini kita panggil close triangle. Okay. Because mention object at rest or stationary, meaning equilibrium. Equilibrium. Okay. So forces are balanced, net force equals to 0. Okay. Or let's say I draw the horizontal one first, P. So this is P. N of P continue to draw the vertical one, W, and then draw out. So you can draw at this angle. Sama je boleh juga terbalik macam ni. Sama. So ini panggil triangle of forces. Okay, the diagram 11.4 shows large number of vehicle using bridge using peak hour. Using appropriate physics concepts such as modification of the bridge structure, so the sepal, characteristic of cable, tower, pillar. Okay, dia punya wire dia yang digunakan untuk ikat tu, ini dia punya tower dia, bangunan dia. Pilar ni dia punya tiang dia, yang digunakan untuk mendirikan bridge tu. Okay, nampak tak sini dia punya tu. Kabel, dia punya bangunan atau menara, dan dia punya tiang. Okay, dan kita nak modify, so 10 markah. Okay, write in table form also for this one, section C. Table. Saya lukis sangat sikit sebab saya pakai board ni susah. Okay, aspect ataupun suggestion. Dan ni punya explanation dia. Okay, the first one, we want to discuss about the cable. The cable is made of steel ataupun stainless steel pun boleh. Ataupun kalau you tak tahu material ni, jangan tulis. Tulis je strong material. Nama material tu kalau you tahu saja you tulis, nanti salah pula. Tulis je strong material. So kalau strong tu, it is not easily break. Okay. Saya lebih suka kalau tulis sentence yang lengkap. Tak mudah rosak atau tak mudah patah atau tak mudah pecah. Okay, can withstand high force. Okay, boleh menahan daya yang besar. Okay, the second point, aspect dia ialah tower. Okay, sama juga. Okay, the tower is made of You can also put steel if you know this one is made of steel also, ataupun strong material. Tower boleh juga kalau nak buat daripada material lain yang strong macam konkrit ke apa. Okay, reason boleh repeat. Not easily atau explanation rates. Okay. Number 3. Third abang. So you boleh repeat lagi kalau ada lagi idea, kita dapat 2, kita nak 3 lagi 3 lagi. Cable can withstand high tension can withstand high force. Okay. We want to discuss about the pillars. Okay. Higher height of pillars. Tinggi pillars tiang tu lebih tinggi. Higher height of pillars prevent water spill the bridge. Okay. Contohnya kalau ombak tinggi dia tak sampai. Okay, number 5. Dan last one, more numbers of pillars. Yang lebih banyak yang lebih banyak maksudnya lebih kuat lebih strong dia punya structure tu. Okay, boleh juga increase stability, lebih stable. Ataupun boleh juga withstand strong wave sebab ombak yang sangat kuat pun boleh rosakkan dia. Okay, jadi you tulis dalam table form sekurang-kurangnya 5 idea untuk dapat 10 markah total dia. Okay. Okay. So for paper 2 SPP, section B and section C, I have discussed. Okay, if you have any question, you can write in comment. I will try to answer it. Okay. So that's all for today. Thank you for watching. Bye.